Big theorem in this chapter is that every closed and bounded set satisfies the Bolzano-Weierstrass property and satisfies the Heine-Borel property, and any set which satisfies either of those properties is closed and bounded. So all three of those things are equivalent. We can't meet one of those criteria without meeting all three of them, which is really cool. It's really powerful, and it's really surprising, especially given how different the Bolzano-Weierstrass and Heine-Borel properties are from one another, and how relatively complex those two properties are compared to just checking that a set is closed and bounded, which is super easy, right? So this is sort of just a skeleton of a proof of one implication in that theorem, which is that if we know that a set is closed and bounded, then we can show that it has a Bolzano-Weierstrass property. And so just to give you the prod, in case you're still working on writing up these pieces, the first part of it, we have to show, if we want to show that K has the Bolzano-Weierstrass property, that any old sequence of points that we pick will have a convergent subsequence. And so for this part, this is where you use the assumption of boundedness. Boundedness is enough, it turns out, to give you the existence of a convergent subsequence. But the problem is we don't know where the limit of that subsequence is, and so that's what part B is all about. And part B, as I think all of your groups have figured out, part B, the important feature that we need of K, is that we need for K to be closed. So, in other words, it's necessary for us to assume that K is both closed and bounded. If I have a bounded set that's not closed, then it might have a convergent subsequence, but the limit of that convergent subsequence might not belong to the set. Conversely, if I have a closed set that's not bounded, then any subsequential limit that it has will belong to the set, but we don't know that a subsequence even has a limit at all, necessarily, if it's not bounded. So both closedness and boundedness are essential parts of this proof. If we get rid of one of them, then we can't prove that the Bolzano-Weierstrass property is satisfied.